Hey, it's Mr. Anderson. This is a quick video on 9.8, the triangle inequality. Basically, it's a simple concept that says, if you look at this triangle here, this is E, F, and D. Any two sides of a triangle added together have to be longer than the third side. Could you try to make a triangle? Try it. Make a triangle with one side and then the next two sides adding up to be shorter than the third side. So if I drew this third side, this side, top one, plus this right little one, added together would be shorter than this side, but it's not connected at the vertex over here, right? So that doesn't work. So the basic idea is that even if your triangle is real skinny like this, these top two sides added together are going to be longer than that third side. And if you can hear that noise, the scraping noise, that's my wife vacuuming the floor above my head. So, on the second floor. So, sorry about that. Anyway, so, it's an inequality, so D plus E has to be greater than F, and D plus F has to be greater than E, so on and so forth. So check this out. Basically, I'm not going to read all of this, I'm just going to go quickly through this, but here's your apartment, here's the school, here's the restaurant. You live 5 miles from the school. Oh, sorry, you can't see all that, can you? Apartment, school, restaurant. You live 5 miles from school. So here's where you are, 5 miles from school. You also live 6 miles from the restaurant. Okay? What are the possible lengths that the school could be away from the restaurant? And just thinking about it here. Wow, that's really loud. Could it be 20? Could that length be 20 miles? The answer is no, because 5 plus 6, let's see if you can see this now, 5 plus 6 has to be greater than x, that third side. Good, she turned the vacuum off. Alright, 5 plus 6 has to be greater than x. So if we do this, this becomes 11 is greater than x. We could rewrite that this way. X is less than 11. Okay, so that third side here, the distance between the school and the restaurant, has to be less than 11. But how small could it be? Could it be really tiny? Could it be like 2? Well, is 2 plus the next smallest side, 2 plus 5, that has to be greater than 6. Is 2 plus 5 greater than 6? Yeah, 7 is greater than 6. Now how can we figure out the exact range? X, okay, your third side, plus the next smallest side, because we're thinking on the small end now, 5, oh great, the vacuum's on again, has to be greater than 6. Okay, so let's solve that. Subtract 5 from both sides. X is greater than 1. Here is our range. And I can write it like this. X is greater than 1 and it's less than 11. Alright, let's see if that's what they got. X is less than 11, X is greater than 1. Alright. So I'm going to move the book over here. Check out this pretty quilt or whatever design we got going on here. Some kid drew this up and he made some measurements of how he wanted it to be, and basically we're going to check and see if these can actually be triangle lengths. So this green one, alright, is 8, 6, and 10. Any combination that you add there will be greater than the other side. Okay? 8 plus 6 is 14, it's bigger than 10. Same over here on this blue triangle. Now this orange one down here is 6, 3, and 9. 6 plus 3 is 9. So that cannot be the dimensions of a triangle, which is why they have a red X through it right here. So in your assignment, you will have a couple easy questions. The harder questions look like this. The lengths of two sides of a triangle are given. What can you say about the length of the third side? And you're looking at my dirty fingernails probably. It's from working on the car again. Alright, so let's do this middle one here. 9 and 11. 9 and 11. What is the third side going to be? I'm going to say T for third side. Well, 9 plus 11 has to be greater than T, right? These two sides have to be bigger than T. So let's do that math. 20 is greater than T. T has to be less than 20. Okay, so that third side has to be less than 20. And how small? That's the biggest it could be. Alright? If it was 20, it'd be too big. So the biggest it could be is 19 point whatever. So the smallest, okay, for each of these problems, like number 6 here, for each one of these problems, you're going to have more like it. You got to think about what's the largest dimension it can be and what's the smallest. So this is thinking about the largest. Now to do the smallest, take the smallest measurement here, so 9, plus your side, your little small side, has to still be greater than the third side by the triangle inequality. Okay? So now subtract 9 from both sides. T has to be greater than 2. T is greater than 2 and T is less than 20. Let's pull my sheet down and see. Between 2 inches and 20 inches. That's right. Okay? So, have fun with the triangle inequality.